Good day. Welcome to CIS 102, Session 7, Introduction. In this study session, we will explain the concept of organizing data. We will as well present a background of managing information covering the principles of database, design, and how to manage data. We will also outline tools for business intelligence. Learning outcomes. When you have studied this session, you should be able to discuss the problems of managing data, resources in a traditional file environment, define the concept of managing information, highlight some important principles of database design, list and discuss tools and technologies for accessing information from databases to improve business performance and decision making. Explain why information policy, data administration, and data quality assurance are essential for managing the firm's data resources. Organizing data. An effective information system provides users with accurate, timely, and relevant information. Accurate information is free of errors. Information is timely when it is available to decision makers when it is needed. Information is relevant when it is useful and appropriate for the types of work and decisions that require it. You might be surprised to learn that many businesses don't have timely, accurate, or relevant information because the data in their information systems has been poorly organized and maintained. That's why data management is so essential. Traditional file processing. The use of a traditional approach to file processing encourages each functional area in a corporation to develop specialized applications. Each application requires a unique data file that is likely to be a subset of the master file. These subsets of the master file lead to data redundancy and inconsistency, processing inflexibility, and wasted storage resources. Problems with the traditional file environment. In most organizations, systems tended to grow independently without a company-wide plan. Accounting, finance, manufacturing, human resources, and sales and marketing all developed their own systems and data files. Each application, of course, required its own files and its own computer program to operate. For example, the human resources functional area might have a personnel master file, a payroll file, a medical insurance file, a pension file, a mailing list file, and so forth until tens, perhaps hundreds, of files and programs existed. In the company as a whole, this process led to multiple master files created, maintained, and operated by separate divisions or departments. As this process goes on for 5 or 10 years, the organization is saddled with hundreds of programs and applications that are very difficult to maintain and manage. The resulting problems are data redundancy and inconsistency, program data dependence, inflexibility, poor data security, and an inability to share data among applications. Data redundancy and inconsistency. Data redundancy is the presence of duplicate data in multiple data files so that the same data are stored in more than place or location. Data redundancy occurs when different groups in an organization independently collect the same piece of data and store it independently of each data. Data redundancy wastes storage resources and also leads to data inconsistency, where the same attribute may have different values. The attribute, student ID, may have different names in different systems throughout the organization. Some systems might use student ID and others might use ID. For example, additional confusion might result from using different coding systems to represent values for an attribute. Program data dependence. Program data dependence refers to the coupling of data stored in files and the specific programs required to update and maintain those files such that changes in programs require changes to the data. Every traditional computer program has to describe the location and nature of the data with which it works. In traditional file environment, any change in a software program could require a change in the data accessed by that program. One program might be modified from a 5-digit to a 9-digit zip code. If the original data file were changed from 5-digit to 9-digit zip codes, then other programs that require the 5-digit zip code would no longer work properly. Such changes could cost millions of dollars to implement properly. Lack of flexibility. A traditional file system can deliver routine scheduled reports after extensive programming efforts, but it cannot deliver ad hoc reports or respond to unanticipated information requirements in a timely fashion. Databases. Database technology cuts through many of the problems of traditional file organization. A more rigorous definition of a database is a collection of data organized to serve many applications efficiently by centralizing the data and controlling redundant data, rather than storing data in separate files for each application. Data are stored so as to appear to users as being stored in only one location. A single database services multiple applications. For example, instead of a corporation storing employee data in separate information systems and separate files for personnel, payroll, and benefits, the corporation could create a single common human resources database. Database management system. A database management system, DBMS, is software that permits an organization to centralize data, manage them efficiently, and provide access to the stored data by application programs. The DBMS acts as an interface between application programs and the physical data files. When the application program calls for a data item, such as gross pay, the DBMS finds this item in the database and presents it to the application program. Using traditional data files, the programmer would have to specify the size and format of each data element used in the program and then tell the computer where they were located. How a DBMS solved the problems of the traditional file environment. A DBMS reduces data redundancy and inconsistency by minimizing isolated files in which the same data are repeated. The DBMS may not enable the organization to eliminate data redundancy entirely, but it can help control redundancy. Even if the organization maintains some redundant data, Using a DBMS eliminates data inconsistency because the DBMS can help the organization ensure that every occurrence of redundant data has the same values. The DBMS uncouples programs and data, enabling data to stand on their own. Access and availability of information will be increased and program development and maintenance costs reduced because users and programmers can perform ad hoc queries of data in the database. The DBMS enables the organization to centrally manage data, their use and security. Relational DBMS and contemporary DBMS use different database models to keep track of entities, attributes, and relationships. The most popular type of DBMS today for PCs as well as for ledger computers and mainframes is the relational DBMS. Relational databases represent data as two-dimensional tables called relations. Tables may be referred to as files. Each table contains data on an entity and its attributes. Microsoft Access is a relational DBMS for desktop systems, whereas DB2, Oracle Database, and Microsoft SQL Server are relational DBMS for larger mainframes and mid-range computers. MySQL is a popular open source DBMS, and Oracle Database Lite is a DBMS for small handheld computing devices. DBMS designed for organizing structured data into rows and columns are not well suited to handling graphics based on multimedia applications. Suppose your company wants to use cloud computing services. Is there a way to manage data in the cloud? The answer is qualified yes. Cloud computing providers offer database management services, but these services typically have less functionality than their on-premises counterparts. At the moment, the primary customer base for cloud-based data management consists of web-focused startups or small to medium-sized businesses looking for database capabilities at a lower price than a standard relational DBMS. Amazon Web Services has both a simple non-relational database called SimpleDB and a relational database service which is based on an online implementation of the MySQL open source DBMS. Amazon Relational Database Service, Amazon RDS, offers the full range of capabilities of MySQL. Capabilities of DBMS. A DBMS includes capabilities and tools for organizing, managing, and accessing the data in the database. The most important are its data definition language, data dictionary, and data manipulation language. DBMS have a data definition capability to specify the structure of the content of the database. It will be used to create database tables and to define the characteristics of the fields in each table. This information about the database will be documented in a data dictionary. A data dictionary is an automated or manual file that stores definitions of data elements and their characteristics. The most prominent data manipulation language today is Structured Query Language, or SQL. Microsoft Access and other DBMS include capabilities for report generation so that the data of interest can be displayed in a more structured and polished format that will be possible just by querying. Crystal Reports is a popular report generator for large corporate DBMS, although it can also be used with Access. Access also has capabilities for developing desktop system applications, improving business using databases. Businesses use their databases to keep track of basic transactions such as paying suppliers, processing orders, keeping track of customers, and paying employees. But they also need databases to provide information that will help the company run the business more efficiently and help managers and employees make better decisions. If a company wants to know which product is the most popular or who is its most profitable customer, the answer lies in the data. For example, by analyzing data from customer credit card purchases, Luz Trattoria, a Los Angeles restaurant chain, learned that quality was more important than price for most of its customers who were college educated and liked fine wine. Acting on this information, the chain introduced vegetarian dishes, more seafood selections, and more expensive wines, raising sales by more than 10%. Data warehouses. Suppose you want concise, reliable information about current operations, trends, and changes across the entire company. If you work in a large company, obtaining these might be difficult because data are often maintained in separate systems, such as sales, manufacturing, or accounting. Some of the data you need might be found in the sales system and other pieces in the manufacturing system. Many of these systems are older legacy systems that use outdated data management technologies or file systems where information is difficult for users to access. Tools for business intelligence, multidimensional data analysis, and data mining. Once data have been captured and organized in data warehouses and data marts, they are available for further analysis using tools for business intelligence. Business intelligence tools enables users to analyze data to see new patterns, relationships, and insights that are useful for guiding decision making. Principal tools for business intelligence include software for database querying and reporting, tools for multi-dimensional data analysis, online analytical processing, and tools for data mining. Online analytical processing, OLAP. Suppose your company sells 4 different products: nuts, bolts, washers, and screws in the East, West, and Central regions. If you wanted to ask a fairly straightforward question, such as how many washers were sold during the past quarter, you could easily find the answer by querying your sales database. But what if you wanted to know how many washers sold in each of your sales regions and compare actual results with projected sales? To obtain the answer, you will need online analytical processing, OLAP. OLAP supports multidimensional data analysis, enabling users to view the same data in different ways. Using multiple dimensions, each aspect of information, product, pricing, cost, region, or time period represents a different dimension. So a product manager could use a multidimensional data analysis tool to learn how many washers were sold in the East in June, how that compares with the previous month and the previous June, and how it compares with the sales forecast. OLAP enables users to obtain online answers to ad hoc questions such as this in a fairly rapid amount of time, even when the data are stored in a very large databases, such as sales figures for multiple years. Data mining is more discovery-driven. Data mining provides insights into corporate data that cannot be obtained with OLAP by finding hidden patterns and relationships in large databases and inferring rules from them to predict future behavior. The patterns and rules are used to guide decision making and forecast the effect of these decisions. The types of information obtained from data mining include associations, sequences, classifications, clusters, and forecasts. Databases and the web. Have you ever tried to use the web to place an order or view a product catalog? If so, you were probably using a website linked to an internal corporate database. Many companies now use the web to make some of the information in their internal databases available to customers and business partners. Suppose, for example, a customer with a web browser wants to search an online retailer's database for pricing information. The user accesses the retailer's website over the internet using web browser software on his or her client's PC. The user's web browser software requests data from the organization's database using HTML commands to communicate with the web server, because many back-end databases cannot interpret commands written in HTML. The web server passes these requests for data to software that translates HTML commands into SQL so that they can be processed by the DBMS working with the database. In a client server environment, the DBMS resides on a dedicated computer called a database server. The DBMS receives the SQL request and provides the required data. The middleware transfers information from the organization's internal database back to the web server for delivery in the form of a web page to the user. The application server software handles all application operations, including transaction processing and data access, between browser-based computers and the company's back-end business applications or databases. The application server takes requests from the web server, runs the business logic to process transactions based on those requests, and provides connectivity to the organization's back-end systems or databases. Alternatively, the software for handling these operations could be a custom program or a CGI script. A CGI script is a compact program using the Common Gateway Interference (CGI) specification for processing data on a web server. It costs much less to add a web interface in front of a legacy system than to redesign and rebuild the system to improve user access. Accessing corporate databases through the web is creating new efficiencies, opportunities, and business models. ThomasNet.com provides an up-to-date online directory of more than 600,000 suppliers of industrial products, such as chemicals, metals, plastics, rubber, and automotive equipment. Formerly called Thomas Register, the company used to send out huge paper catalogs with this information. Data management policies. Setting up a database is only a start. In order to make sure that the data for your business remain accurate, reliable, and readily available to those who need it, Your business will need special policies and procedures for data management. Establishing an information policy. Every business, large and small, needs an information policy. Your firm's data are an important resource, and you don't want people doing whatever they want with them. You need to have rules on how the data are to be organized and maintained, and who is allowed to view the data or change them. An information policy specifies the organization's rules for sharing, disseminating, acquiring, standardizing, classifying, and inventorying information. Information policy lays out specific procedures and accountabilities, identifying which users and organizational study sessions can share information, where information can be distributed, and who is responsible for updating and maintaining the information. Ensuring data quality. A well-designed database and information policy will go a long way toward ensuring that the business has the information it needs. However, additional steps must be taken to ensure that the data in organizational databases are accurate and remain reliable. Happen if a customer's telephone number or account balance were incorrect. What would be the impact if the database had the wrong price for the product you sold, or your sales system and inventory system showed different prices for the same product? Data that are inaccurate, untimely, or inconsistent with other sources of information lead to incorrect decisions, product recalls, and financial losses. Inaccurate data in criminal justice and national security databases might even subject you to unnecessary surveillance or detention. According to Forrester research, 20% of U.S. mail and commercial package deliveries were returned because of incorrect names or addresses. The incidence of such errors is rising as companies move their businesses to the web and allow customers and suppliers to enter data into their websites that directly update internal systems. Before a new database is in place, organizations need to identify and correct their faculty data and establish better routines for editing data once their database is in operation. Analysis of data quality often begins with a data quality audit, which is a structured survey of the accuracy and level of completeness of the data in an information system. Data quality audits can be performed by surveying entire data files, surveying samples from data files, or surveying end users for their perceptions of data quality. Data cleansing, also known as data scrubbing, consists of activities for detecting and correcting data in a database that are incorrect, incomplete, improperly formatted, or redundant. Study session summary. In this study session, we discuss the problems of managing data resources in a traditional file environment and how they are solved by database management system. We presented the background of managing information covering the principles of database design and how to manage data. Eventually, we outlined the tools for business intelligence. End of study session 7. Thank you for listening.